Hello students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Now we have learnt about the geometric sequences, we have learnt about the geometric means. Today we will be starting with this topic, finite geometric series. And what is the meaning of this term, finite geometric series? Suppose we are having this geometric sequence 2, 4, 8, 16, 32, dot. This is an infinite geometric sequence. And I want to find the sum total of the first 4 terms of this infinite geometric sequence. So, what do? I select the first 4 terms. As soon as I am selecting the first 4 terms, it no longer remains an infinite geometric sequence. It gets converted to a finite geometric sequence. Okay? And I am interested in getting the sum total of those 4 numbers. It is 2 plus 4 plus 8 plus 16. And this is equal to 2 plus 4 is 6, 6 plus 8 is 14, 14 plus 16 is equal to 30. So we are being able to get the sum total of the first 4 numbers. Therefore, what is the necessity of having a formula? The necessity is that we are being able to get the sum total of 4 numbers. But what if we are interested in getting the sum total of 100 numbers? Of course, you are having a calculator and you can just input the 100 numbers one by one and the calculator will be giving you the sum total. But that will be taking some time. So, therefore, we use the formula that is given to us. But before going to the formula, some of you may have heard of the term infinite geometric series. So, you may argue that if a finite geometric sequence can be converted to a finite geometric sequence, a series, why can't an infinite geometric sequence be converted to an infinite geometric series? Of course, it can be converted to an infinite geometric series, but whether or not you will be getting the sum total of all the infinite number of terms depends on a certain condition. If that condition is met, then we can get the sum total of all the infinite number of terms. But that is not the topic of our today's session. Okay? That will definitely be a topic of one of our future sessions. But for today, we are interested with this topic, finite geometric series. Okay? So the sum of a finite geometric series with the first term as U1, common ratio as R and the number of terms as N is given by the formula Sn. Sn is the sum total of the first n numbers of a finite geometric series, which is equal to U1. U1 is the first term times R to the power of N. R is the common ratio. N is the number of terms in the series which we are interested in getting the sum total. Okay. The series of which we are interested in getting the sum total, that is the number of terms present in that series, is given by this variable n minus 1 divided by r minus 1. This is the first version and this is the second version. You see, U1 is the same and only the r to the power of n minus 1, they have just interchanged the position. The minus sign is remaining the same both in the numerator and in the denominator. In the numerator 1 and r to the power of n, they have changed their positions, and in the denominator r and 1, they have interchanged their positions. Okay, that is the only difference. So let us first of all find the validity of this formula, the two formulas that they have given us. Okay. So I am using this very series that I have taken, and it is containing 4 terms, so it is S4 equal to U1 is equal to 2. The first term is 2. And common ratio is also 2. N is equal to 4. Minus 1 whole divided by, I am writing this way because I don't have any space. So divided by r minus 1, which is 2 minus 1. Okay. So what is the numerator? 2 to the power of 4 is 16. 16 minus 1 is 15, and 15 times 2 is 30. So it is 30 divided by 2 minus 1, which is 1. So S4, we are getting the value of S4 as 30 over 1, which is 30. This is the same as the number 30 that we had got previously by just adding the 4 numbers, and that is obvious, quite obvious, because we are adding the same numbers. And as I have said before, the formula is useful because, of course, you can use the formula for getting the sum total of the first 4 terms or sum total of the first 2 terms. Doesn't matter how many terms you are taking, but actually it is useful when you are having more number of terms or the numbers are quite big. Okay. So now we have checked the validity of this formula. You may check the validity of this version also. Okay. So now that we are confident that these two formulas are correct, let us try to derive these formulas. We write Sn. Sn is equal to the sum total of the first n numbers of the finite geometric series, which is having the first term as U1. So we start with U1. What is the second term? The common ratio is R, therefore the second term will be U1 times R. Third term, U1 times R square. Fourth term, U1 times R to the power of 3. Okay. This will be continuing. Since it is the summation of the first n terms, so I have to take the nth term. What is the nth term? It is U1 times R to the power of n minus 1. Okay. But I am seeing R to the power of n in the formula. Therefore, let us multiply this equation by R. If we multiply this entire equation by R, the first term becomes U1 times R plus U1 R square plus U1 R to the power of 3 plus U1 R to the power of 4. It continues plus the last one is U1 R to the power of n. Okay. So let this be the first equation, let this be the second equation. And we will be subtracting. We will be performing this operation. We are subtracting the equation 2 from the equation 1. So, since we are subtracting, the signs will be changing and all the terms will be having negative signs. Okay? All of them will be having negative signs. Now this is U1R. We are subtracting. So let me first of all write the left hand side. It is Sn minus R times Sn is equal to U1. And this is plus U1R and this is minus U1R. So I can safely cancel them. Coming to the third term of the first equation. It is u1 r square, and the second term of the second equation is negative u1 r square. So I can cancel them. This is plus u1 r cube. This is negative u1 r cubed. Okay. So this will be continuing, and these two will also be getting cancelled. You will be able to cancel them. So we will be having only the first term and the last term from the second equation. It will be u1 minus u1 r to the power of n. Okay. And I can take Sn common. It becomes 1 minus r is equal to, if u1 is taken as common from this side, it becomes 1 minus r to the power of n. Okay. So this is equal to Sn equal to u1 1 minus r to the power of n over 1 minus r. So this is this form that we have derived, this formula. How do we get to this form? I'll be just taking out the minus sign. Sn is equal to, I am writing this as u1, and I am taking out this minus sign. This can be written as r to the power of n minus 1 over, again I am taking out this minus, and it becomes r minus 1. Okay. So this is Sn equal to negative u1 r to the power of n minus 1 over negative r minus 1. So now you see you are getting this form. Okay. So these are the two forms of the same equation, the sum total of the first n terms of a finite geometric series. So let us now start with the questions based on this topic. Okay. We start from the very basic question. Find the sum of the following series. They have not said what type of a series is this. You have to find out. Of course, this is a session from the finite geometric series topic. Therefore, it is obvious that the series will be a finite geometric series. But in your examination, they won't be giving you the chapter name, or the topic name. Therefore, it is your duty to find out what type of a series is this. It is definitely not an arithmetic series because there is no common difference between the terms. Let us try to find whether there exists any common ratio between the terms or not. Okay. If there exists a common ratio, then it will be a geometric series. So u1 is equal to 12. That is certain, guaranteed. Now let us try to find the ratio. I am taking the first two terms. It is 6 over 12, which is equal to half. Okay. I am taking the second and the third. First I have taken these two. Now I am taking these two. 3 over 6, which is also equal to half. So there exists a common ratio. You may take the third and the fourth terms as well. So this is the common ratio, half. Okay. And half is in a fractional form. I may convert it to a decimal number, 0.5. But I am converting it to a decimal number because it is a terminating decimal number. Half can be converted to a decimal number and it is a terminating decimal number. It is exactly equal to 0.5. But in case you are having the r value as say 1 over 3, never convert this to 0.3 recurring. Never. Okay. Because These are trivial questions, but you may have a difficult question where you will be needing the R value frequently. And if you write this, you will not be taking the recurring, you will be either taking 0.333 or you will be taking 0.33. These are all approximations. Okay? So never take a recurring decimal equivalent representation. If you do not have an exact decimal representation, it is always better to keep it in fractional form. You may approximate in your final answer stage. But throughout the calculation, you keep the value in fractional form. Okay. So now that we know U1, we know R, what is the value of N? That is what is needed. It is up to 10 terms. So N value is equal to 10. Now we are in a position to get the sum total of the first 10 terms. Let us take the first form for this question. It is S10 equal to U1. So it is 12 times R to the power of N. R is what? 0.5. To the power of N. N is 10. Minus 1 divided by R minus 1. 0.5 minus 1. So what is this equal to? S10 is equal to, definitely for this we will be needing a calculator. So it is 12 times 0.5 to the power of 10 minus 1 divided by 0.5 minus 1. Okay. So what is the value? It is 23.9766. If I take up to 3 significant figures, it will be 24 approximately, 24.0 approximately. Okay. So it is approximately equal to 24.0. This is our answer for this question. Okay. Now let us move on to the next question. Find the sum of the first n terms of the following series. Again, they did not mention what type of a series is this. So let's start with our answer. It is a geometric series because there is the common ratio. First of all, let me write the first term. It is equal to root 3. What is the common ratio? It is, if I take the first two terms, it is negative 3 over root 3, which is equal to negative root 3. This is equal to R. I can show you this is the same ratio that I'll be getting if I take the second and the third terms. So this is 3 root 3 over 3, it's negative 3, right? So this is equal to negative root 3, which is equal to R. Okay. So negative root 3 is equal to R, the common ratio, and U1 is equal to root 3, and we do not know the value of N. They are just saying find the sum total of the first N terms. So it will be Sn. So Sn, and for the previous one I had used the first form of the formula. So let me take the second form of the formula, okay, for this question. So it is root 3, U1 is equal to root 3, and 1 minus R is equal to negative root 3. So it is negative root 3 to the power of N over 1 minus r. So 1 minus negative root 3. This will be the value. Okay. So let us just simplify this part a bit. So this is root 3. I cannot do anything for the numerator. I don't think I'll be able to do anything to the numerator part. It will be negative root 3 to the power of n. But the denominator gets changed to 1 plus root 3. And usually we do not keep an irrational number in the denominator, so we have to rationalize. We will be multiplying both the numerator and the denominator by 1 minus root 3. Okay. So Sn is equal to, I am multiplying root 3 times 1 is root 3. And root 3 times minus root 3 is negative 3. So root 3 minus 3. And we are having 1 minus root 3 to the power of n. This is our numerator. And what is our denominator? I am using the a plus b times a minus b formula, which is a square minus b square. So it is 1 square minus root 3 whole square. Okay. So this is equal to, I keep the numerator as it is, 1 minus root 3 to the power of n over 1 minus 3, which is equal to negative 2. And I don't want a negative 2 to stay in the denominator, obviously. So what I can do is, I can keep it as a negative number, which I don't want. So what I am doing is, I am just taking the negative sign out from that part, and I am writing this as 3 minus root 3. Okay. And the second part of the numerator remains the same. And this is negative 2, so I can cancel these two. Okay. So Sn, the sum total of the first n terms of this geometric series, should be equal to 3 minus root 3 and 1 minus root 3 to the power of n over 2. Okay. So this should be our final answer. This is our final answer. Okay. So students, let us stop over here for today. We'll be meeting very soon in our next video session. Thank you for watching this video till the end. Please give this video a like in case you found this useful. Please subscribe to my YouTube channel. It will be motivating me to make more math videos which may help you in your math classes. Okay? And do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. I am making videos, one video every day from Monday to Friday. And these videos are based on the chapters of the IB and the IGCSE math curriculum. Okay. So bye for now.